All right, let's move on to lesson 17.2. Similar figures. Now, similar is different than congruent. Okay, similar, we're gonna have some of the same types of rules, but they're gonna prove similarity, not congruent. Similar, let's see over here. Similar are polygons, or whatever shapes. Okay, we're mainly dealing with triangles, so they're the polygons that have the same shape. Okay, but they could be different sizes. So same shape but different size. So two triangles could be similar. One could be bigger than the other. Like you could have a triangle like this, and a triangle, let me draw one inside of it, a smaller one. Those two triangles are similar because their angles are all the same. That's one of the rules. They're similar, but they're not congruent, okay? So as we get going here, we'll see what's going on. So polygons are similar if their corresponding angles are congruent. Okay, so if all the angles of one are congruent to all the angles of the other, they are similar. Okay, that's just like I drew on that, over here. Okay. Now, the corresponding sides, now this is where it becomes different. The corresponding sides, they match up as fractions, so we call those proportions. So if the corresponding sides are proportional, just like we did in 17.1 assignment, if you can set up the ratio of the sides, or the fraction of sides, equal to a fraction of another side, then they're going to be similar. The ratio, next bullet, the ratio of corresponding sides is called the scale factor. Okay, so if you have a scale factor, that means something is 3 times as big. So it would be a scale factor of 3 to 1. Or something is 1/16 as big, that's smaller. It'd be a scale factor of 1 to 16. Okay, and you'd write that as like your fraction, scale factor 3 to 1, or 1 to 16, or whatever. Okay. If polygons are similar, then their perimeters are also proportional. So the perimeter of one figure, so over here, if I had, say, this one, and we had the perimeter of this one, if I added all 3 sides, that's the perimeter. Okay, 3, 4, 5, let's say. So the perimeter of that would be 12. So the perimeter of this figure, say to the perimeter of another one, that's what, 12 over, let's say 2, 3, and 1, 12 over 6, okay? That ratio, perimeter of one triangle versus the perimeter of the other triangle, that can be set up to equal the ratio of the sides or anything else, okay? Any other side ratio, I guess is what I should say. All right. So scale factor then, the way it's set up matters. Okay, so if you're scale factoring from one figure to another, you have to write it in that order. So in this figure, it says, what is the scale factor from triangle ABC to triangle DEF? Okay, so that means we have to start with ABC compared to DEF. So this would be the ABC compared to DEF. All right, so let's pick, here are the two figures, pick a side. If they're similar, then let's see, side AB would match with side DE. So 8 to 12, what does that reduce to? Let's see, divide those both by 4. That would be 2 over 3. So this would be the scale factor. And if you did any of the other sides, like say 10 over 15, 10 over 15, that should reduce to 5 goes in 5 and yeah, so 2 over 3. 14 over 21, both divided by 7, that'd be 2 over 3. And then the perimeter, 8 plus 10 is 18, 18 plus 14, 28, 29, so it'd be 32 compared to the perimeter of this one. 21 plus 12 is 33, 33 plus 15, 33, 43, 48. And those both, that should reduce to 2/3 like all the others. So if I divide those both by 8, now I can divide it by more. 16, 16 goes in twice, 16 goes in 3 times, yeah. So the perimeters have the same scale factor, and the ratio of the sides have the same scale factor. And notice that the way it was written, ABC to DEF, we had to make that as the fraction. The top one, the first one, bottom one, the second one. Okay, let's go to the next question. What is the scale factor of DEF to ABC? So we're going the other direction now. We're going from DEF to ABC. So that would be, what, 3 over 2? Because ABC to DEF was 2 over 3. So if we're going the other way, DEF to ABC, then we'd have to it'd just be the reciprocal. What is the ratio of the perimeter? Oh, DEF to ABC. Oh, I just did that up here. It's 48 over 32, right? Which reduces to 3 over 2, just like the others. Okay, so we're just showing that all those rules are true. All right, a similarity statement. Okay, just like the congruent statement, sides and angles have to match up. So a valid similarity statement must match the corresponding angles and sides. Write a similarity statement for the triangles above. So if they're similar, we're going to use the little similar notation, which is this single squiggly. Okay, that's all it is. So if I say triangle ABC, I don't have to write that one first. I could write the other one first. But then just the one squiggly, similar to triangle DEF. But if I wrote ABC, I have to write DEF. Okay, if I wrote those letters in any other way, I'd have to write these in a different way to match. Okay, so this right here, that little single squiggly, is the similar notation. All right, so example 1, list all congruent angles and write a proportion that relates the corresponding sides. Okay, so the congruent angles. Let's see. What's going to match up here? I have J would probably match with P. L would match with what? N, and K with M. So I'm just going to mark those, J with P, L with N, and K with M. And I'm going to write down the two triangles. I'm going to say, okay, triangle JLK is similar to triangle PNM. Okay, so now I have the similarity statement. And the way it didn't tell me the similarity statement to begin with, but I just looked at the figures and matched up what looked like to be the way they should be written. So I have the statement here. Now I can match up angles. So angle J would be congruent to angle P, J and P, L and N, K and M. So angle L congruent to angle N. Remember, in similarity, the angles are congruent. Angle K congruent to angle M. But the sides are not. They are proportional. Okay, they could be congruent because they'd have a proportion of 1, but not always. So what's going to match up? So JL, side JL, would match with side PN. So since I wrote the JLK triangle first, then I'm going to say that JL goes on top and PN goes on bottom. So that would equal the ratio of another side. I'm going to have to write it underneath here. So I could write it over here. JL. So let's go LK. So LK would match with NM. LK and M. And that would equal also, what, J to K, P to M. J, K, or P to M. So any of those fractions could be set equal to each other. Any three of those in any combination could be set equal to each other. All right, so we use that then, just like all the others, we'll solve here. So example 2, if we know that AGM, so that's this one, AGM is similar to KXD, okay, if they're similar, then we know we can set up fractions of the sides, because we're given sides, it looks like here. So we can set up fractions with the sides. So we're going to start with AGM. That's going to go on top because that's written first. So if I take 32, okay, that's going to be, let's see, AG, so that goes with KX. So that's going to go over X plus 3. There's that fraction. So then GM, that should match up with XD. Yes, it does. Okay, according to the statement. So GM is 36, and XD is X plus 6. So now I've created a proportion, and just like the first assignment, and we now can cross multiply and solve. So if I take 32 and multiply to X plus 6, I get 32 times the X and 32 times the 6. So what's 32 times 6? 192. And then I take the 36 and multiply it to the X plus 3. So 36 times the X and 36 times 3 is 108. And now let's see, I'm going to subtract 32x. So I have 192 equals 4x plus 108. And now I'm going to subtract 108. Subtract 108. So 192 minus 108, that's 84. Now that's going to equal 4x. Divide by 4, x will equal 84 divided by 4 would be 21. Okay? So now x is 21. And if we needed to find the value of the side, you would just plug it in and find out what it is. Okay. So on your practice, you're just going to do that same type of thing. Okay, you're going to match up angles and sides according to the similarity statement. The sides, remember, they're written as fractions. The first triangled side over the second triangle side. Okay? And number 3, this is saying, even though this is a different figure, scale factor is still the same. You still match up the sides and give the scale factor. Notice how they want the scale factor to be written. They want it from written scale factor A to B. So A would be on top of the fraction, B would be on the bottom part of the fraction. Okay, on all these figures, doing the scale factor. And number 7 is just like a question we just barely did. 8, 9, same. You're just matching up sides, setting up proportions, and solving. And number 12, it asks you, it gives you the scale factor. So there's your fraction, 3 over 5. There's one fraction you can use, 3 over 5, right now. And you want to find the perimeter of the other one. So you set up the perimeter of 1 over x is going to equal 3 over 5. And there you go. All right, 17.2.